Why did I multiply by that number? The reason I multiplied by this number is I want to have something in this expression that reminds me of a slope. I want something that reminds me of a slope. So first I'll look at this numerator. Okay? I'm going to take these two parts and put them together. Okay? And then I've got this yi minus y bar over here. Okay? And over here I've got my sum from 1 to n of xi minus x bar squared. And now here I've got my xi minus x bar. What part of this looks like a slope? What part looks like a slope? Let me erase this so that I have kind of two separate fractions here multiplied by each other. The part that should make you think of a slope is this. What is this quantity? Yi minus y bar over xi minus x bar. How do you calculate the slope of a line between 2 points? Just in general, just in high school math class. If I have the x and y for one point and the x and y for another point, how do I calculate the slope of the line between those two? Rise over run, right? Difference in the y values divided by difference in the x values. This quantity that I put in the circle is just the slope of the line that connects any particular data point to the point x bar, y bar. So there's some point where x is equal to the mean of all the x's and y is equal to the mean of all the y's. And that quantity that I put in the orange circle right there is the slope of the line that connects those two. For every point in the data set, I could draw such a line and calculate its slope, right? Okay? It's the slope of the line connecting each data point to the middle. One way to think about this quantity right here, my favorite way to think about this quantity, is essentially as an average of those slopes. Let's calculate the slope connecting each point in the data set to this middle x bar, y bar, and then average those together. That's what this expression says. But we're not just adding up these slopes and dividing by how many there are. Instead, we're taking a weighted average, where some of the points are more important than others. If I were just adding them up and dividing by how many there were, right, what would I do? I don't want to erase this, so we're going to imagine for a moment, okay? Here are my slopes. If I cover up this part, then I'm adding up all of my slopes. And suppose I have 10 data points. If I wrote 1 over 10 where my hand is, then this would say add up all the slopes and divide them by 10. Right? If I had 110 here. That's the same as saying 1/10 times each slope, add them all up. And I get the average of all those slopes. But what's actually there? Not 1/10, but rather this quantity. What is this quantity? It's the squared difference between the x value and the mean of x divided by the sum of all the squared distances between x's and the mean of x. This value here is a proportion. And if I were to calculate this value for every point in the data set and add up these values, they'd add up to 1. They're weights. Instead of 1/10, for some of the points this is 2/10, for some of the points this is 1/20, but they all add up to 1. These are weights. So multiplying each of these slopes by a weight, adding them all up gives me a weighted average. So what are these weights? What determines how much influence a particular point has on the final slope I get? Well, the further xi is from x bar, the bigger this value will be, right? The closer xi is to x bar, the smaller this value will be. The points that have x's very far from the mean of x have the most influence on what the slope is going to be. The points that are very close, so here, like if there's a point here, xi minus x bar is very small. Those points have little influence. My favorite way to think about the estimate of the slope of the regression line is as a weighted average of the slopes between each point in the middle, where the weights are determined by how far the points are from the middle. Is that a good way to weight the points? It's one way to weight the points. It's one way to do it. What's the motivation for weighting the points that way? Why would we have more influence on the points that are further from the middle in terms of x? Let's draw one more up there. So if you look at these points, it's pretty clear that we should have a slope that's positive. So I can start to wave my arm. Here's some possible regression lines that might make sense. But notice as I wave my arm, the middle of my arm is always kind of in the same place. As I consider different possible regression lines, it's the values on the ends that are changing, not the values in the middle. Right? In fact, we've said that my regression line, by definition, is always going to go through x bar comma y bar. So really, for x's that are very close to the middle, we don't have a lot of leeway in terms of how big the residuals are going to be. But for the points on the end, right, for that point way up there, this line isn't nearly so good as this line, even though they're very similar for the points that have x equal to 20. So the way the conventional regression line works is that it tries to minimize the sum of the squared residuals, and it puts more weight on the points that are further from the middle based on x. So that means if I had one more point that was way out here in terms of x, but only like a little bit lower than you'd expect possibly in terms of y, that's really going to affect the slope of this line a lot. Right? Without that point, the slope might look like this. With that point, it's going to go down quite a bit because this point is going to have a much larger influence on the final slope than any of the other points because it's further from the mean of x. So my favorite way, I'll put a star on it, of thinking about how to interpret the slope estimate is as a weighted average of slopes. To me, that makes sense. I want to estimate the slope of a bunch of points, so let me see what the slope is between each point in the middle and weight them all together.